Assalamualaikum to Dr. Ridwan. Today our group would like to present LoRa and LoRaWAN technologies. LoRa and LoRaWAN technologies is a wireless communication technologies designed for low power, long range communication for Internet of Things application. So LoRa is the physical layer modulation, meanwhile LoRaWAN is the higher layer protocol stack that enables long range communication and support features. So the things that we done research for this assignment is the coverage range of LoRa and LoRaWAN, signal strength, and also the power consumption. So for the power consumption part, we have done research on the relay function, which is the usage of aggregation mode in order to see the difference between the power saving potential in LoRa and LoRaWAN protocol. So these are the experimentation that have been done. So basically this graph clearly illustrates that the number of messages transmitted without aggregation mode is significantly higher than with the aggregation mode. So the graph revealed that the number of messages transmitted in the aggregation mode is equivalent to the number of transmitted if the isolated node were connected as a LoRaWAN gateway, essentially forming a cluster. So for example, we can see that there is only one relay node and the number of messages transmitted without aggregation mode is approximately 20, whereas with the aggregation mode, it reduces to around 5. So as the number of the relay node increases, the difference between two modes become even more pronounced. So for instance, with 10 relay node, the number of messages transmitted without aggregation mode is around 200, while with aggregation mode, it decreases to around 20. So the reason behind the high number of messages transmitted without aggregation mode is that each message is sent individually, even if they pertain to the same event or data. So this results in a larger quantity of message being transmitted as the isolated node sends each message separately. Conversely, in aggregation mode, multiple messages are combined into a single message, which is then sent to the LoRaWAN gateway. Then by utilizing the aggregation mode, the number of messages transmitted can be significantly reduced, improving network efficiency and also reduce the usage of power consumption.
Next, we will move on to the proposed scheme for the LoRaWAN network for enhancing the coverage range. So what we came up with is a LoRaWAN network with multiple receive antenna integrated with dual concentrator antenna. So basically, a LoRaWAN network usually utilize single base station with single antenna. So we proposed a dual concentrator antenna which utilize two base station. So we need to use two sets of concentrator and antenna. On top of that, we added a multiple receive antenna for each base station. So this is the proposed scheme to enhance the coverage range. So as we can see from this MATLAB simulation that we wrote, we found out that the average signal strength for single antenna is lower compared to multiple receive antenna. So this is for both of these simulation is for dual concentrator antenna, meaning two base station. So each base station for this first one have a single antenna, and for the second one, each base station have a multiple receive antenna, which is 4. Okay, so average signal strength is or in other words, we call it a receive signal strength indicator, RSSI, is a measure of the power level of the received signal. So a higher RSSI value indicates a stronger received signal, and it generally corresponds to a better coverage range. So if we see that this average signal strength is higher, means that the coverage range is also better. So we can conclude that our proposed scheme have managed to enhance the coverage range. As we can see, the average signal strength is better compared to single antenna.
So for the challenge and future research direction, first we have range and coverage. Factors like terrain, obstacles, and interference can affect the signal strength and limit the network's range. To overcome this, we need to study how signals travel, create better antenna designs, and plan network deployments more effectively. Next, for the network capacity, with the increasing number of IoT devices, it becomes crucial to manage the network capacity efficiently. LoRaWAN networks must handle a large number of devices simultaneously without compromising performance. Research is needed to develop smarter network protocol, find ways to control congestion, and allocate resources dynamically to improve network capacity. And the last one is about the security and privacy enhancement. To ensure the security and privacy of data transmitted over LoRaWAN networks is a major challenge. So IoT devices are vulnerable to various security threats such as unauthorized access and data tampering. So to overcome this, we need to implement secure key management and design secure authentication and control mechanism for LoRaWAN devices. So for the future direction, first scalability and network performance. To explore the ways to make LoRaWAN networks support more devices and handle higher traffic loads, this may involve improving network protocol using advanced scheduling algorithm and understanding how network density affects performance. Next is energy efficient enhancement, which is develop strategies to make LoRa and LoRaWAN device use less energy and extend battery life. This could include optimizing communication protocol, managing power more efficiently, and exploring energy harvesting technology. And the last one is interoperability and integration with different IoT protocol, which is seamless integration with different IoT protocols and enhance interoperability across IoT system. So based on this topic, the conclusion is that LoRa and LoRaWAN offer a promising solution for low-range, low-power IoT communication. And moreover, the challenge of optimacy include range, coverage, network capacity, security, interface, and quality of service. Hence, for the future research, it concludes the scalability, energy efficiency, interoperability, localization, machine learning, and edge computing. Lastly, overcoming challenge and exploring new directions with advanced LoRa and LoRaWAN for diverse IoT applications.